So as the quotient, u equals 1 minus cos x, and u dash equals minus, well, if we differentiate minus cos x, we get sin x. V equals 1 plus sin x, and v dash is cos of x. So dy by dx is u dash v minus u v dash all over v squared. So that's sin x plus sin squared x minus cos x plus cos squared x. Now the sin squared plus cos squared on the top gives us 1, then we've got plus sin x minus cos x, and we have a bottom line of 1 plus sin x all squared. Nothing else simplifies. Part 1, the vertical asymptotes, nice and easy. We have a bottom line which has x plus 1, and you can see here x cannot equal minus 1, so the vertical asymptote is x equals minus 1. Part 2, the non-vertical asymptote. Well, what we have here is an improper algebraic fraction, so we have to divide x plus 1 into x squared plus 3. X then, x times x is x squared, x times 1 is 1x. Subtract, so we have 0x take away 1x is minus x, and 3 take away 0 is 3, and I'll then have a 3 here, so 3, I beg your pardon, I'll not have a 3 at all, I'll have a minus 1. So what do I multiply this x by? To get this, I multiply by minus 1. Minus 1 times x is minus 1x. Minus 1 times 1 is minus 1. Minus x minus minus x is 0, and 3 minus minus 1 is 4. So what I can do is write the function as y equals x minus 1 plus 4 over x plus 1. And what we have here is the non-vertical asymptote. So the non-vertical asymptote has an equation y equals x minus 1. So the x-intercept occurs when y equals 0, x squared plus 3 equals 0, x squared equals minus 3, and that means there is no x-intercept. The y-intercept occurs when x equals 0, and if x equals 0, y equals 3 over 1, which is 3. So we've got 0, 3 as a y-intercept. Now, after our division, we were able to write the function in this form. All I've done is moved the bracket up, so I have x plus 1 to the power of minus 1. For stationary points, dy by dx equals 0. So we have 1 here, and that's going to be minus 4 x plus 1 to the power of minus 2, and that equals 0 for stationary points. Now, 1 minus 4 over x plus 1 squared equals 0. I can split these up, and the term becomes positive. Then multiply by x plus 1 squared. If I take the square root of both sides, I have x plus 1 equals plus and minus 2. which means that x is minus 2 minus 1 and plus 2 minus 1. So I have stationary points at minus 3 and 1. Y of 1 is, let's see, it's 1 minus 1, which is 0, and 4 over 2, which is 2. So I have a stationary point with coordinates 1, 2, and then when x is minus 3, I'm just using this line here. So it's minus 3 minus 1, that's minus 4, that's minus 4 minus 2, so it's minus 6. So dy by dx equals 1 minus 4 lots of x plus 1 to the power of minus 2. And for the nature of the stationary points, I'm going to find the second derivative. So that'll give me 8 x plus 1 to the minus 3, which I'll write as 8 over x plus 1 cubed. Now when x equals 1, d2y by dx squared is greater than 0, which means that 1, 2 is a minimum. And when x equals minus 3, d2y by dx squared, let's just consider that minus 3 plus 1 is minus 2, minus 2 cubed is minus 8, that gives us a value less than 0. So minus 3 minus 6 is a maximum TP. So here is the graph set up. The axes are drawn. We've got the asymptotes at x equals minus 1 and the non-vertical asymptote at x, y equals x minus 1. Minus 3 minus 6 is somewhere down here, and that's going to be a maximum, so we'll have something of this sort. We have a y-intercept at 0, 2, 0, 3 rather, and we have a stationary point at 1 along 2 up, just somewhere here. So I think what's going to happen is we'll have the graph coming down like so, down to its minimum, and then up like this here, and that's the point 1, 2. So the auxiliary equation is m squared plus 9 equals 0. M squared equals minus 9, and m equals plus and minus the root of minus 9. Plus and minus the root of 9 times the root of minus 1, and that's plus and minus 3i. So the complementary function then is y equals a cos of 3x plus b sine of 3x. Now, when it comes to the next part of the problem, deciding on a particular solution, we see that the right hand side cos 3x is also apparent here. So that means that the particular solution has to include an extra x, so we're going to have cx cos 3x plus dx sine 3x. Now we want to find the first derivative. So what we have here is a product. Differentiate the first, leave the second, and leave the first, and differentiate the second. Similarly for the second term, differentiate the first, leave the second, leave the first and differentiate the second. And we have to work out the second derivative as well. So c cos 3x, that's no longer a product because we don't have an x, so it's just going to be minus 3c sine 3x. Second term is a product. I should have simplified that, tidied it up, but differentiate the first, leave the second, leave the first, and differentiate the second. Next term is 3d cos 3x. And the very last term, it's a product as well, so differentiate the first, leave the second, plus leave the first and differentiate the second, so it's minus 9 dx sine 3x. Now the equation we had to deal with was y double dash plus 9y. So y double dash plus 9y equals cos 3x. Y double dash. Now let's simplify this as we're going on. So that's minus 6c sine 3x. And we have 6d cos 3x. And we have minus 9 cx cos 3x minus 9d x sine 3x plus 9 lots of y. That's the very first line here. So it's 9 lots of cx cos 3x plus 9d x sine 3x, and that all equals cos 3x. Now you can see these two terms cancel out with these two terms. That means that we're left with a very simple minus 6c sine 3x plus 6d cos 3x equals cos 3x. Now we don't have a sine 3x term on the right hand side, so minus 6c then equals 0 and c equals 0. We do have 1 cos 3x on the right hand side, so 6d then equals 1 and d equals 1 over 6. So if we put that value back, the particular solution then is, it was c cos cx cos 3x plus dx sine 3x. So we have 1 over 6 x sine 3x. And that means that the general solution is y equals a cos 3x plus b sine 3x plus 1 over 6x sine 3x. What we have to do now is to find the values of a and b. We know from the information given that when x is pi by 3, y equals pi. So we can sub these two values in pi here. Pi by 3 times 3 is pi, so it's a cos pi plus b sine of pi plus x is pi by 3, so it's pi by 18 sine of pi. Now the sine of pi is 0, these two terms then are 0. We know that cos of pi is minus 1, so a then has the value minus pi. So a is minus pi, that means we can write y as minus pi cos 3x plus b sine 3x plus 1 over 6 x sine 3x. So we've still got to find the value of b. We're told that dy by dx when x is 0, so we'll need to differentiate the line above. Y dash then is 3 pi sine 3x plus 3b cos 3x. What we have here is a product. Differentiate the first, leave the second, so it's 1 over 6 sine 3x plus 3 over 6, which is a half, 1 half x cos 3x. And if we sub in the values 1 and 0, so 1 equals, well, sine of that's just going to be 0. That's going to be 3b cos of 0. The cos of 0 is 1, so the next term is 3b. And plus 0, plus 0. So 3b equals 1. And b equals 1/3. So the final solution then is minus pi cos 3x plus 1 over 3 sine 3x plus 1 over 6 x sine 3x.